Hello, this is Miss Timmons, and today we're going to learn what does it really mean to complete the square. Mathematically, you're taking the term x squared plus bx and making it a perfect square. Recall that a perfect square is a product of a polynomial multiplied by itself. For example, x plus 1 times x plus 1. You can think of completing the square as transforming a rectangle into a square. So let's start with this plane figure. It's a square. Both sides have a length of x. So that would mean that it has an area of x squared. So let's say that instead of a square, we now have a rectangle. Now let's examine the area of the rectangle. Well, the blue piece has length b with x. So the blue piece has an area of bx, and we already knew that the orange was x squared. So this rectangle has an area of x squared plus bx. Let's transform this rectangle into a square. I want to do that by cutting the b in half. So now the dimensions of each blue piece is b over 2 by x. The area hasn't changed. I just want to cut them in half so I can rearrange the pieces like so. When I rearrange those two pieces, you can see that we're closer to having a square, but there's only one part missing, and all we have to do is complete it. Hence the term complete the square. So we know the dimensions of that piece. It's b over 2 by b over 2. So now that the square is completed, we can investigate the area of each piece to determine what our new area would be. We already knew that the orange part was x squared and that the total of the blue was bx. But since we cut the pieces in half, I just want to demonstrate finding the area of each piece and then putting it all together. So as mentioned, the final part that completed the square was b over 2 by b over 2. To calculate the area, the only thing that I need to do is to add all the area of the squares and the rectangles together. So we now have completed the square and simplified it, but remember we want it as a perfect square. So we want the product of a polynomial times itself. So if you go and look at our square, you can see that the dimensions are x plus b over 2 times x plus b over 2. So what we're going to do here is just take the length times the width and multiply them together. X plus b over 2 times x plus b over 2. And we want to write that as a perfect square, so we'll just write it as x plus b over 2 squared. Now let's work on a practice problem more like what you would see. So we're going to start with this rectangle whose area is represented by x squared plus 10 times x, 10x. So now we want to take this rectangle, transform it into a square, and complete it. First thing I did was split the blue part in half. So instead of 10x, I have 5x and 5x. Now I want to rearrange those two pieces. My area hasn't changed, I just rearranged. And finally, I want to fill in the last piece that's missing, which is going to be a tiny little 5 by 5 square. So now I just want to gather all the areas of my squares and rectangles and add them all together. And as you can see, this is going to simplify to x squared plus 10x plus 25. But remember, we want a perfect square. So we want to see what it's going to look like as a polynomial multiplied by itself. And when we investigate our new square, we can see that the length is x plus 5 and the width is x plus 5. So we just want the product of those two. X plus 5 times x plus 5. And we're going to now rewrite that as a squared term. X plus 5 squared. Now I'm going to rework the exact same problem, but without using the geometric representation. So let's complete the square of x squared plus 10x. Remember, we have our x term, so to get the last term, we just want half of b, which is 10 over 2, squared. The next step is just simplification. And keep in mind, we want to write these as squared terms. So in order to get that perfect square, I want to factor it. Just a mini lesson on factoring. We're looking for two numbers that have a sum of 10 and a product of 25. And that's pretty simple. Those numbers would be 5 and 5, since 5 plus 5 is 10 and 5 times 5 is 25. So now when we go to factor, we have x plus 5 times x plus 5, and we always want to rewrite it as a squared term, so we'll rewrite it as x plus 5 squared. And there you have learned to complete the square and a little bit of why it's called completing the square. Hope you learned something.